Okay, any questions before I get going? So I got an email from someone in instructional design who said, at the end of the semester, the students, they all gave these presentations. And of course, it's a really beneficial exercise for the team that gives the presentation. But sometimes it's not so joyful for the other ones who have to suffer through the presentation. And so my my thought was always that actually one learns best by negative example. And so if you see other people struggling through a presentation that's really horrible, you learn what not to do. So it can't be all bad, because of course we all have to give lots of presentations in our professional lives. But the advice from the instructional research person was to say, well, make sure that you ask a question upon one of those presentations on the final. And so that seems like a sensible suggestion. So just to make sure that everyone actually does show up and listens to all of these presentations, I will ask a question about one of them, randomly selected on the final. Yes?
How's the presentation? Do you like a PowerPoint or anything like that?
You do not have a PowerPoint. You send me a set of HTML files that you use with any tool that you like or will discover that produces HTML files. So on the Piazza page, I gave a few suggestions of what you might use. Yeah?
Since we are using the GitHub for this project, can we use a GitHub page too?
Yes, totally. You can just put your things on GitHub pages. If you know how to do that, that's of course easy. Yeah. And in that case, I don't really care how you produce it. Yeah. So what like I said, what I would like you to do is to discover one of those slide programs that way you can enter the slides in HTML or Markdown or such a thing, so that you discover an alternative to PowerPoint. Any questions about what you need to do next Tuesday and next Thursday? All right. So let's get back to that final lecture of the semester. Yeah, in that case, you want to make sure not to have them checked into version control. So we were talking about locks, and I'm going to go through them just really quickly because I then have a few questions about them. So what we wanted to avoid is that multiple threads can access the same piece of code. And so the easy way to do that is with a lock. So there's this class reentrant lock. And you have an object of that class, and then you use it to protect what's called a critical section. So some piece of code that you want to make sure runs to completion without being interrupted. The way you do it is you call lock on the lock, and then eventually you call unlock, and no other thread can enter if one thread has called lock until that same thread has called unlock. So that's a fairly straightforward mechanism to do that locking. Then there is a refinement that you sometimes need. That sometimes it happens that in a method that has acquired a lock, which you don't see here because I didn't write it down, that method needs to give up the lock temporarily. In that case, it can call a wait on a condition object. One has to ask the lock to produce a condition object. So here we have the lock. It can produce a condition. And on that condition object, then one can call a wait. And some other thread has to call signal all on the same condition so that the first thread can proceed. And that way you can deal with things like acquiring the lock and then checking whether one can even make progress, and if no progress can be made, to temporarily give up and let someone else change the condition of this object so that later there's hope again. So we've studied that, and then we had this telephone analogy. Just yesterday I was reading some educational paper that said you should never, ever teach anything with analogies because it's a cognitive load on the students that it's actually harder to figure out which part of the real-world analogy applies in this situation and which part doesn't. And one should just teach it in a more mechanistic sense. So that may be true. I didn't actually know that. So if you found the telephone analogy confusing, by all means forget about the telephone. So then we went on to the intrinsic locks that Java has had since Java 1.0, and I said they're more concise, but they're potentially confusing. What's nice about them is that in the common case, where you have a method that at the very start needs to lock, and then at the very end it needs to unlock, then instead of doing the locking and the trying and the finally and unlock, you can just tag that method as synchronized. Now, which lock doesn't lock? So this is something where in Java, every object is given one lock for free. And it doesn't even have a name, it's just a name. Of course, you may have millions of objects in your program. Not all of them will actually have the lock. It's only going to be supplied because it's a costly thing. It's only supplied for those who need it, but when it's needed, it's there. And so, in a simple case where you have like this data structure Q, then it makes sense to have a single lock that protects all of the operations. You then simply need to tag all of the operations as synchronized, and you're kind of done. If you need to worry about waiting a notification, then you call wait and notify all, and that applies to the single condition, which has no name, that comes with a lock that has no name. And in a simple situation, that actually works perfectly nicely. So, but then I said, it could be complicated. You could have a situation where you use these synchronized blocks, so you're allowed to access the lock of an object, of any object, with this synchronized block syntax, where you say, okay, I want to know, this synchronized just means lock here and unlock here. You want to lock the lock that belongs to obj, and then you want to unlock it at the end. And some people use this as a feature. They say if you want to, for example, if you have a data structure that does not intrinsically have synchronization, then you could make it so that as long as whoever wants to use that data structure acquires the lock on that before doing anything with it, then presto, that previously unsafe data structure is now thread safe. And yes, that's easy to do, but it's also easy to make mistakes if you don't do it perfectly. So my recommendation was not to do that. But because this is something that no certification exam would be without and all that, I thought I'd ask a few questions about that. So let me get those up. So here we have a great example of such a synchronized block. And so this is very similar to the code that we've seen last time, except I'm not using a reentrant lock, but I'm using this thing called QLock. So what is QLock? It's an object. Remember, any object has a lock, so I can use this particular object as a lock. And so here I'm locking the lock. Over here, I'm unlocking it. At the end of the synchronized block, it automatically is unlocked. And then I'll do the exact same thing, of course, on the remove method of this queue. And I claim there's something wrong. Yeah?
You use wait and then signal off, not wait notify off.
Ooh, that's my mistake. Yes, okay, I didn't even mean to do that. Because I didn't even have that condition. So how the heck would I even do that? Oh, I see what I would have to do. Yes. So let me fix that real quick. So the way I would need to fix it is because I don't have a condition. And so I can't use the condition. Here, as you correctly say, I have to use notify all. On what do I call them? Previously, if you look at the slides, what did I call him on? Well, there's two versions. There was the version that has the reentrant lock, and then I asked the reentrant lock, give me a condition, and then I called it on the condition. But then when I used the intrinsic locks, I called wait and notify all, not await and signal all. On what? Those of you with photographic memory, what did I call him on? On the object, which really then means on the lock that that object has. So if I just call wait and notify all, that indeed would be another terrible puzzler that I had never thought of. What's wrong with that? So this is where so I'm getting the point across that these intrinsic locks are more subtle than anything. So let's see what this means. So now we're locking on QLock, which is this object over here. And now let's say that there is no space available. And then I call wait, but I'm calling it on the wrong thing. I'm calling it to some other lock, namely the lock that belongs to my instance of this Q. So if I have a Q Fred, then Fred has a lock, so now I'm calling this on Fred's lock. What happens when I wait on this? It'll throw some exception, because you can only call wait on the lock that you're currently holding. So it doesn't make any sense to call wait on a lock that you're not currently holding, because the semantics of wait means to give up the lock that you're currently holding and to sit around and wait somewhere. And so that's an obvious programmer's error, and then an exception would be thrown. So that doesn't work. So what do I have to call wait on? Yeah? Exactly. Very good. So I call it on the QLock. And also do the notify all on the QLock. Okay, so now this is much better, and it's almost correct now. But there's still one fatal flaw. And to see that, imagine that you have two queues. So imagine that you have a process where a bunch of threads do some work, put the work into the first queue, another bunch of threads pulls them out, refines the work in some way, puts it in a second queue, and then finally the consumer pulls them out of the second queue and finishes it. So now you have two queues. How many locks do you have? So each of them has a private object QLock, right? So the first one has private object QLock, and what is it? It doesn't really matter. Any old object will do. But what particular object was chosen here? The string LOCK. So the second queue is now constructed. It also makes an instance variable private object QLock. And what's the lock? The same string, right? Because this happens to be a string constant. All string constants are interned. So this is the exact same string reference. So it's the same object. And so that now means that if someone is trying to get, if someone is locking the first queue, the second one is also locked. And so one can easily come up with situations where that makes your program into a deadlock. So that's bad, and it's kind of subtle, right? Because you kind of think, this is an instance variable, so clearly everyone has their own, but it doesn't matter what it is initialized with. It's easy to fix. How would I fix it? Yeah? Yeah. Or for that matter, say new object. Right. Or if you want to save a couple of characters, new long. 4 characters instead of 6. Pick the shortest class that you can find, and that has a no arc constructor. And yeah, that's good enough, right? So and now it works. So now this is a perfectly good replacement. But you can see that there's actually value in using the entrant locks because it makes everything explicit. So here I have a similar error, and so unfortunately now I've messed this thing up everywhere. So let's ignore this part here right now. But as you can see over here, I've changed the synchronizing. What's wrong with this? Yeah. Yes, in every call, it's a new thing, right? And that doesn't work at all because the whole idea of locking is that there's like one central lock that coordinates all of the threads. Here, each thread is going to construct its new lock, and so you'll have no exclusion. It's not a very common error, but it does happen that people accidentally do that. So that would be bad. So here we are back to our condition here. I don't even remember what's wrong with this one anymore. So you guys need to help me out. I hope something is wrong. Oh. Oh, yes. So if you look at this line here, so with conditions, we call await and signal all. So why does it compile? Every object has a method called wait. And so that's a super easy mistake to make. I've made that mistake. Right? So every object has a wait. That means that you wait on the anonymous condition of the anonymous lock of that object. Yes, it has to be await because you want to await on the space available condition. And we talked about that on Tuesday. So I asked, why did this is such an obvious, easy mistake to make? Why didn't they fix it? They could have made it so that wait would have, they could have overridden wait to throw an exception or something, except that wait was defined as final. And so they could do nothing. They couldn't even deprecate it because you can't deprecate the final method of your superclass. So that's unfortunate. Right, here we have another one. So here I have a different method in the same bounded queue where I'm writing out the contents of the queue to a file. It's a human urge. So here is the writing part. And then if there is an error, then I make sure to close this file. And I'm also making sure that I unlock the lock. Because if I didn't unlock the lock, then if there was some exception happening in here, then the lock would continue to be locked and no one else could do anything with that key. What's the error? Yeah.
There's no lock that's been declared.
Oh no, I mean assume that there is, right? And what would we? So assume that there is that reentrant lock from before. No, no. So this code here, I think is. I mean, I made it to be great. So I'm making a new file name. I print a bunch of stuff to it, and I think this part is all correct. So and like I said before, if there's an exception happening here, then the finally block kicks in. No, it doesn't wait. It just does it. The only reason that I want to lock and unlock is I don't want anyone else to add or remove from that queue while I'm writing the contents up. It has something to do with the IO exception. So, yeah, go ahead.
When the block is interrupted, the IO sector output is.
So let's say this thing here throws an IO exception. Right? Then what happens?
Out is closed.
Then out is closed, and?
There's no way to fix the problem.
No, that's okay. That's okay. I mean, then what else is it going to do? I mean, the most likely reason, then it'll throw the exception out and the caller will know. Right? I'm not losing the exception. Yeah? What about an interrupted exception? Okay, that's a very good point. So let's see where an interrupted exception could happen. Who could throw an interrupted exception? Could QLock.lock throw an interrupted exception? I think it can. And that's fine because then it wouldn't lock. And so then it would never be locked. The interrupted exception would be found. I might have to declare it. So that might be a bug that I have to say comma interrupted exception. That's good. But there's one more. And in fact highlighted the offending line. What's the problem with out.close? Yeah? It can. Out.close can throw an IO exception. And that would be very bad because then we don't unlock. And so anytime, not just with locks, when you see more than one line of code and a finally clause, you really wonder. Because what if this one throws an exception and then the finally isn't as finally as you thought it was? The best remedy for that is to not do this close in this finally clause, but instead use another try block in here and make this one here one of those try with resources blocks. Then there's an implied finally at the end. And then this try with the implied finally takes care of the out resource, and this try finally takes care of the QLock resource. So as a general thing, a try finally should only deal with one resource at a time. When you use the try with resources, you can have multiple resources. You could say semicolon and then some other resource in here. But unfortunately, locks are not resources. So as a reminder, a resource means something that is auto-closable, where the close method gets called in the end here. So why didn't they make locks auto-closable? They could have just renamed unlock into close. That would have been much nicer. I would have been able to say, try with the try with resources and not have to worry about all that finally stuff. Why can't I do that with locks? The way the try with resources works is you say try, a variable, and then you initialize it with something. And then at the end, whatever that variable was, .close gets called. But notice that this variable here is now initialized with something that we're newly constructing. With the lock, that's not what we do. We're not constructing the lock. That lock is shared, and it has been constructed a long time ago. So that's why it doesn't work in try with resources. So ever since try with resources came about in Java 7, I believe, finally, almost no one uses finally anymore, except with locks. It's the only time that I've ever used finally. Oh, except maybe there's one other exotic situation. I guess that's all I have. Okay, so those were my puzzles. And so the 2 points I wanted to make with these puzzles is that, number one, that these intrinsic locks are inherently difficult. And so if you ever run into them, because someone feels that they're part of Java and every Java programmer should know about them, you have to know, but for your own programming, I would stay away from them. The reentrant locks, if you ever have to do that, have the advantage of being more explicit. And the other thing is that the flip side is with these reentrant locks, that lock unlock with the final lock is very, very sensitive. If you mess this up, you can keep a lock permanently locked. And so you should just mechanically always say, try finally. All right, back to the lecture. So we talked about these thread-safe queues, and if we have time, we'll do a little lab with that. So as the very final thing, I wanted to show like a fun little example where one can make use of this. So let me see if I can quickly run this. So this thing makes a little animation here of a sorting algorithm. Can anyone tell what sorting algorithm? So it's merge sort. So I'll run it again so you can verify that. So you can see how it keeps merging together the halves into larger halves. So it visits them, and now that's the final merge. You don't see everything, right? You don't see that second array into which it copies them, but it gives you an idea of how that works. So how do I do that? Now that sounds like something you'd want to do. And so the way I've done it is I'm making this super cheap. I don't want to actually implement merge sort. Except here I did implement merge sort. What I really want to do is I just want to call the library sort, and I could have done that. I don't know why I didn't do this here. I guess just to show that this is merge sort. So what I've done here with merge sort is here, it is a completely unchanged merge sort. There's nothing really in here that has anything to do with threads or anything. If you look at it, and I guess that's why I did it like this. If you look at it, it's just copied from a standard CS2 textbook. There's nothing in there with threads, with animation, with delays, or whatever. Where the delay comes in is I'm passing a custom comparator that calls sleep, and then after it has slept, it returns the comparison result. And that call to sleep is what makes it run kind of slow. Exactly, because otherwise it would be over in an instant. So when you look at what it paints, so at any time, so we have an array, and at any time you call repaint, then it paints the current array just as a bunch of bars, and it knows that one of the bars is marked. That's the one that's set with marked or marked 2. And So when you set the values, then you pass the current array and the ones that should be marked. Here's the frame. I don't want that one. Find the one that I want. So here's my comparator. And so the comparator like I said before, does two things. One is it sleeps, as I said before. And notice that unhappily I have to catch the interrupted exception here because this is the compare method and it's not expected to throw any exceptions. So it sleeps, and just before it sleeps, it tells the panel what to paint. So the key observation is I didn't change the sort algorithm, but I made it so that the panel does the repaint before it goes to sleep. And that's all I had to do. So this is a generally useful mechanism that you can use to animate all sorts of algorithms. You have to write a class that draws the algorithm state in some way. And whenever something interesting happens, then you change the state. This method here, if you pay close attention to the previous slide, it calls repaint. And then you go to sleep for a little bit. And then that one's done. So in terms of threading, let's look at, there's one subtlety that I'm not actually talking about in the book, but I probably should. That's my, so the sorting happens in a separate thread, and that's how it should be, because if I were to do the sorting in the animation, in the user interface thread itself, then I would block the user interface. If someone was tired of it, they would not be able to close the program any sooner. But doing it in a separate thread is just fine. That's something that maybe I should have covered for those of you who do the collab violet. You may have noticed that the collab violet people, that when your program contacts the server as because of a button click or something, at that point your program is kind of frozen. Did any of you notice that? Because at that point the user interface thread that's supposed to be dealing with mouse events is now busy waiting for the server to come. There is a way of overcoming that, and we haven't covered that yet. So if someone wants to know before next Monday, for extra brownie points, send me an email and I'll give you a short article on what you can do to overcome that. There's a fairly easy way to do that. In fact, in Android, if you were to try to do that, if you were to try to do work on the user interface thread, your program would crash. Because the Android developers got tired of people writing code like that, so they sense that and make sure that you can't do any real work on the UI thread. So we're not doing that. We're doing all the work on a separate thread. Now I wanted to make this a little bit more sophisticated, so let me just show the other program. Okay. Yeah. So this is the same program, except now I made a button here, so whenever you click the button here, then it makes one step. And so you can see the thing step by step. And I could click the run button and then press run on its own, and I can click the step button again and then do that step by step. So that's if you wanted to watch this kind of thing in detail. So how do you do that? That one is a little harder. Okay, so let me just give a bit of background on that whole thing. So think of what you do in main in any user interface program. So you have the main thread. And so what does it do? It makes a new frame. And then it calls like set visible and a bunch of stuff. What is it? Set title. And at the very end it says set visible true. And at that point, what does the main thread? What does the main program do? It exits. That's the last line of main. And so that means the main thread is now truly dead and gone. So your program is still alive, so there must be some other thread that is alive. And in fact, there are at least two. There's one thread that's somehow internal that we don't really know anything about it, that Swing uses internally. And then there's what's called the UI thread that runs. And that takes care of button clicks and things like that. So for example, if there's an action performed, then the action performed happens on this thread. And so let's say that 2 buttons are clicked, then it's naturally serialized. One action performed happens here and another action performed happens afterwards. And they come one after another. Why do they come one after another? Because the events are queued up. This thread here, the one that we don't really know, it's the one that's internal, puts all events on a queue. This thread here pulls the events off a queue and executes whatever it is that one needs to do to handle the events. That's all it does. And so this queuing naturally makes it so that no 2 methods that can be button callbacks or whatever other callbacks or events can happen simultaneously. And that greatly simplifies your programming model. That way you never have to worry whether you could somehow mess up a shared data structure by two handlers. All the handlers happen one after another. There were experiments with user interface toolkits that didn't have this protection, and people would forever mess something up. One thing that's easy to mess up actually is the internals of Swing. If you, in one of those threads, start a new thread that, say, imagine you have a more complicated Swing data structure like a tree, and messes with the tree, and the other one also starts a new thread and messes with the tree, that tree will get corrupted in no time, because those structures are not threads. And but as long as you don't start new threads in any of these callbacks, then it's perfectly safe. So that's why they did like that. But it does have one disadvantage, that if in a button handler you want to do some long action, like contacting a server to get some information, then that means that the entire UI thread now is waiting for the server. It's now blocking on an I/O call, and then the next action performed doesn't happen. So the user will furiously click other buttons or drag sliders or something, and all that means is that this thread here will queue up more events.
So in the sense of the full animation we had, when you do the sort separately so that.
Yeah, so I did that in a completely separate thread, that. And I'll show you the code for that.
So does that mean it all sorts independently?
Yes. So let's see. I think we'll see that in here, where I did this. So over here, I make a new thread pool and the sorter, which comes out of here, which makes so trust me, there's a runnable sitting inside here, and that one gets executed on a separate thread. But here, so the critical question is, how do you make it so that the sorter thread blocks until the UI thread says, okay, keep on going again. So let me show exactly what that means here in this app. So right now, the sorter thread is blocking. It's not progressing. And when I hit on step, then it goes for one more step, and then it blocks again. And so how do we achieve that blocking? And the trick that I wanted to illustrate here is that what you want to do is you here's what you don't want to do. You don't want to say, well, maybe I use a shared variable and a reentrant lock. What you want to do is you want to say, is there some pre-existing data structure that one can use that is thread safe? And so in this case, what I simply did is I used a blocking queue. It's kind of overkill, but it works beautifully. So the way it works is that the button click adds a string, either run or step to the queue. And now let's see what the sorter does. That is this one here. It tries to take something out of the queue, and if there was nothing in there, then it naturally blocks. The next handler for step will put in a step. And then over here it'll sleep. So this is what it does when it runs. So when the command was a step, then this run thing doesn't happen. Then in fact it'll just make one step through this thing, and that'll be the end of it. If it was a run, on the other hand, then it sleeps for a little bit, and now it has consumed the run, so it puts another one in. So by using a queue and just adding and removing strings, I know it's thread safe, and I can get this behavior. You just have to think through it a little bit, what that is. And it's not that interesting right now to me that we do this in detail. The point that I want to make is that if you ever need to do some kind of a synchronization, try a queue first. It'll be thread safe. You don't get bit by any concurrency issues. Don't mess with semaphores or any of that things that they taught you in your OS class. It's not worth it. You can usually do any kind of simple synchronization surprisingly easily with the queue. Just, remember, you can put something in, you get it out. That's a safe operation. Blocking is safe. If you need to just look at something, take it out and put it back in. There's nothing wrong with it. And you just think of some protocol that makes your thing work. All right, so that's all I want to say here. Let's see, do we want to do the lab? So I resurrected that lab that I lost last time. But given that we only have 20 minutes, I don't think it's going to really be super worthwhile. So instead, what I'd like to do is spend 5 minutes in going over what we've done for the entire course and talk a little bit about the final, because I don't know how much time we'll have after the presentation. So just as a recap of the course, so the course had kind of 3 objectives. It was supposed to teach design patterns, and we've seen lots and lots of design patterns, and so looking forward at the exam, there will be at least one question on the exam that says, here is some situation from the Java library, from one of your projects, from whatever. Here is a design pattern. Show me why this is an example of this design pattern, or show me why it isn't an example of the design pattern. There was a situation like that in the midterm that you can look at for guidance. And I'll come up with a couple of more exercises that you can review. But so I will give you a list of design patterns, not all of them in the book because that's too much for the exam preparation, but 4 or 5 or 6 that you need to be familiar enough with that you can recognize when do they apply and when do they not apply. So design patterns are important because it's a good way of sharing design guidance. Another part of the course that we wanted everyone to know is that the basic tools of object-oriented design languages, so that you can read basic UML, that you can produce basic UML. At one point, there was this vision that everyone would always write lots of UML. That's not the case in modern software development. But just about everyone can recognize a class diagram. Everyone can recognize a sequence diagram. And they are effective tools. So I want you to be able to use those tools. I will have an exam question or two where I give you a diagram, and I might ask, why is it wrong? And it's not hard for me to find such a wrong diagram because you have graciously supplied them in abundance. So I will just say, show me something that's wrong in there. Not because that's necessarily a useful skill, but it shows that you can read it. And I will ask you to produce a short diagram about something or to enhance a diagram. And so what I may simply do is like give you a violet diagram and say, now that you all have some version of violet, and say, change it in this way or in that way. That way you don't have to draw a whole thing from scratch, but I can quickly assess whether you can do that kind of thing. So that that's an important communication tool that you're expected to use. And the third thing is, of course, the team project. That's an important part of the course. So I appreciate the feedback that you gave me for what to do better for next semester. And so I thought it was interesting that a bunch of people asked for more homework in the second part of the course. So I'll see how I can. Yes, some of you look with astonishment. So some people said, it is easier to follow the material if there is actually some programming homework with it, and I agree with them. That it's more real, and you're forced to think about it more. So I can't really make the project shorter because, as all of you know, it takes a certain amount of time to just get done. So 6 weeks is like the shortest amount of time that I can think of. But I could maybe make it so that there's one homework assignment in the middle. So I'll think about that. But the project is very important to us because it's the first team project that it's the first required team project that everyone has to take. And sadly, it's only one of 2 required projects in the entire curriculum. There's no other course other than CS 160, which is a projects-only course that requires team projects. Our employers are forever unhappy about that. They would want us to require more projects. So that means for you, if you have the chance of taking other courses that have a project, such as the mobile programming or the web programming class, those are good classes to take. Employers value that experience because, as you have seen, it is hard. I have a whole inbox of unhappy teams that say this doesn't work, that didn't work. And the first time that happens, it's often hard, particularly in such a short program, to do much about it. So for those of you who have had a less than happy experience, I hope the next time will be better. And it usually does get better because you see these problems happen early. And also, if there's problems with the teammates who just don't even show up, then more of them will get washed out later in the program. But the team projects are really important. And I must say, I've been very gratified how the use of Git has just worked. I mean, that has exceeded my expectations. At first, it was hard to get everyone on board, but by the end, I mean, this really has been working well. So I've been telling some of my colleagues about what I do to have a quick look at your project, and so that is progress. And so being familiar now with these tools will make it a lot easier for the next project that you're doing because you can hit the ground running and you don't have to learn everything. There was 1 or 2 people who said, "My God, I just got out of community college and I learned it with the C++, and now I have to make the switch to Java and to the goddamn terminal." And that's true. It is a big jump, but the goddamn terminal will save you bacon many times over. So even if it was painful this time, I hope that you will remember that. And so it was a bit of a mishmash course because then it also had this extra idea that you should be knowing everything about all of Java. So remember, we talked about the Java object model and a whole bunch of kind of fiddly Java internals, and they're all very interesting from an object-oriented point of view. And one has to. It's really good to know them. So the idea was that we learn several programming languages in a bachelor's program. So you of course have Java. Then you're supposed to learn some C and maybe even a little bit of assembly that you can use in your operating systems course, and then some functional language such as Scheme and 152. But Java is the one language that we'll learn in depth. And so the hope is that when you graduate, you have at least seen every part of what is in Java at one point. And so we've gotten a lot further in that. There's still, I'm sure I could baffle you with some arcane parts of Java, but you've seen an awful lot at this point. So I particularly like this course because I put it together like 15 years ago or so, and so I'm glad that I have the chance to rewrite that book. It's pretty rough this time, but next time it'll be better. And so if anyone is actually reading the book and finds typos, then let me know. So in the final, as I said, we're going to be seeing a bunch of questions on object-oriented design and patterns. There will be some programming question. What did we do in the midterm with programming? Yeah, so it was a modifying of the homework. So I will look at whether the very last homework that we did just before starting the project is suitable for an exam, and if so, I'll let you know on Piazza to have one more look at that, because that way we all start with some basic code. What I will do is I will have at least one question where for each team, I will pick something out of your code. So every team member better be familiar with the entire code base, not just what you wrote yourself. But it'll only be your own team. You don't have to decipher something from someone else's team. That would be asking too much in a short exam. But so be familiar with your own code. I will ask something about somewhere in there, just to make sure that everyone who works with the team at least has done that much. That's really all I can think of what's going to be. So no multiple choice, none of that stuff. It's going to be like the midterm. But you'll have more time because now it's going to be over 2 hours. And I won't put in 3 times as much material. So it'll be about this, maybe one more question in the midterm. But I hope it would not be a rushed experience. Same thing as before, laptops and everything. So bring those in. Yeah.
This question is probably kind of related to the concern that we're going to have in the class. Like my biggest fear, since whatever time I have spent on this class outside of the classroom has been trying to figure out what we're doing with the project.
Yeah.
And so the concern is that we have the labs, which will be a little bit helpful.
Right.
But when I think about how to study for the midterm, how much time and emphasis do I need to put on like practicing the coding that's involved in the last couple of chapters of literature?
Right. So and I'm aware of that. So what I'm going to be doing is I'm going to give you a list of labs to review.
Okay.
I think that's the easiest way for us to have some common code, and that means that there'll be some lectures that I'm just not going to be able to ask questions about in the final, and it's like, I mean, you can't do everything. Yeah.
Can you also give us the solution
Of the labs? Okay, here's what I would like to do is, because I won't have time, but if you guys want to share the labs on Piazza, go for it. Or in any other way. That seems like if someone has a question and saying, can someone post a good answer? I may have answers ready and then I can just post them. But right now I'm working on this grant application that's consuming every waking minute of my time. So I'm not sure how much time I would have to prepare and organize those.
Yeah, I was just thinking, because in a lot of the labs, you actually did them.
Yeah, so if I did them and they happen to be captured on the video, then you can just watch the video. That's why actually sometimes when there was like you guys were working and I had nothing better to do, I kept let the video roll and just was coding. I figured that way whoever needs to review it, they could. Anything else? Yeah.
How do you design a object-oriented program? Because I think it's kind of intuitive to some level.
Right. So that's a very good question. Right? How do you like professionally say, here I have this problem. How do I do the object-oriented thing? And so there's really no wonderful recipe. So if you go back to the chapter 2 of the book, I try to say, look at what are all the likely candidates for objects, for classes, see how they collaborate. But that only gets you so far. And a lot of times it really is kind of experience that you have seen successful patterns of interaction before. And then you say, well, that kind of pattern of interaction worked. And so now I'm going to try that again. Or you kind of look out for signals that if you can organize your program so that a lot of common stuff gets done in a superclass, like with a template pattern, for example, then that kind of gives you an idea that you're on the right direction. because you can, your program then looks kind of spare and elegant. But it's super hard to give a recipe that says, how to move from this problem to this object-oriented design. And so that's why we're doing things like trying to draw it up. And so when you draw it up with a UML diagram, you often feel unhappy about something, that it seems convoluted or not as nice as something that you've seen somewhere else. And then that gives you an idea to try harder. Or if you know some of the patterns and you recognize one of them and say, this is just like something that you've seen before in different situations, then that might give you an idea that you're on the right spot. But there really is not a recipe. And so that's one of the reasons that I wanted you to mess with an existing, somewhat non-trivial program that when you looked into Violet, where you saw a bunch of patterns successful use and then you added your own stuff to it, that just gives you some more experience. That's something that you can follow. So if you think about back in CS1, in CS1 people ask me for always, can you just give me a recipe on how to write these loops? Because students hate it. They say, write something that finds the maximum of an array, that finds the position of a maximum, that swaps the maximum with the minimum, that does all of these nasty things, that removes the maximum. They want a recipe, right? Because it's very frustrating for beginners. Now you guys are all past that. That's how you made it this far. Could you write such a recipe? Could you give a systematic way on how a CS1 student could pass that course and do all of these various pesky loop problems? It's hard, right? You kind of say, well, now you know it because you've written a large number of them. And I think that's kind of what it's like. So all I can do is show you a few good examples of collaborating object patterns and maybe a couple of bad examples, and hope that then you can go forward with it. And it gets harder when you get to the next level. Now you know how to make programs that consist of maybe 10 or 20 classes. If people write programs that consist of hundreds of classes, and they ask themselves, what is a good architecture? And the only answer we have to that really is patterns and experience. Well, that's actually a great question to conclude the course. All right, so I'll see you on Tuesday for those presentations. And if you have any questions in the meantime, let me know.
So, it looks like our time is on the 16th.
I think that's